5.3 Minimums, maximums for quadratic functions. So we've spoken about quadratics and we know that they have a vertex. The vertex is also called, though, a minimum or a maximum. Which one it is, so is it a minimum or a maximum, that depends on the overall shape of the parabola. And I'll just do two examples and hopefully they'll make sense. So looking at this parabola over here, hopefully you can see that the vertex for this parabola would be at 2, -5. That's why this is such a nice one to work with. Okay, so we could graph that, and that means that the vertex 1, 2, 3, 1, 2, 3, 4, 5 would be at 2, -5. Okay, and then after that, if I'm just interested in the overall shape of this parabola, then I need to look at this number over here, 4. So in this case, if a is 4, a being the leading coefficient, then we know that the parabola goes up. And we could actually say it goes up pretty fast, right? 4 times as fast as normal. But that gives me enough information to tell you that if this parabola goes up, and it goes up pretty fast, so it may look something like this, then the vertex in this case is called a minimum. So when a is larger than 0 and the parabola goes up, we will have a minimum. Can't write minimum right now. Let's try that again. Okay, if the parabola looks like this, it's a lot harder to see the vertex. Well, you can't see it, so I'd have to do like a negative b over 2a, which would be a -4 divided by 2 times a -1, which is in +2. Then I would still have to plug this in. So I actually don't really even need this. Okay, I can just look at this and realize that, well, that's a -1 times x squared plus 4x plus 6. That means that this parabola, in general, the shape means that it goes down. So on this one, I'm not even going to graph an xy coordinate system. I just know that overall the shape is down. So if that is the overall shape, then the vertex in this case is a maximum. Okay, so this was when a was less than 0. So the general rule for determining the minimum or the maximum of a quadratic would be look at the leading coefficient, which we call a, right? If the leading coefficient is positive, if it's larger than 0, the parabola would go up. So then we have a minimum. And if a is less than 0, the parabola would look like this, and we have a maximum. Excuse me. Okay. The minimum maximum is really tied into like word problems. So we'll do a word problem. I have to introduce a very typical word problem first, and then hopefully you'll see sort of what I mean. Excuse me. So the height of a rocket, assuming that there isn't any air resistance and it's a vertical launch, so that means that the rocket goes straight up when it's launched, can be described or modeled by St equals a -16t squared plus VOT plus S sub 0. Okay, we've worked with this. This is very similar to our marble drop. We just need to sort of know what all these parts stands for. So the letter sometimes it's a lowercase, sometimes it's a capital. Okay, so the letter S, that would be the distance. I have no clue why they use an S for that. The letter T stands for the time, like how long has the rocket been in the air. This V sub 0 is the initial velocity of the rocket. That would be how fast is the rocket going when we launch it. And then S sub 0 is the height from which the rocket is launched. So if I gave you a word problem like this on a test or a quiz, I would probably give you this. I would give you the general form, but then you would have to figure out what each of these values are and plug it in based on what I'm giving you over here. Okay, so some of you may be wondering, what is the negative 16? So what is the negative 16? So when we did the marble drop, so when we had the marble and we just dropped it, what acted on the marble? Well, that was gravity, and gravity is a constant. This is the gravity constant. It represents the fact that when you shoot a marble up, gravity keeps pulling it down, so it's a negative force relative to the force up. Okay? So the negative 16 somehow represents our gravity. Alright, so how high does a toy rocket go up into the air if it has an initial velocity of 200 feet per second and it's launched from a pad that is 2 feet tall? So let's see. So the distance after a given time is a negative 16 t squared plus v sub 0 is the initial velocity. That's v sub 0. So we do 200 t plus from a pad that's 2 feet tall. So that's S0. So you just literally plug it in, and then you can work with it. So there's the there's the function that models this particular problem. Now let's see, what does it say? How high does the rocket go up into the air? Well, that's asking, another way that I could have asked that is, what is the maximum height that the rocket will go? Well, that is a maximum, that's a vertex question. So let's find the vertex and see what happens. Okay, the vertex is a negative b over 2a, which is in this case a negative 200, because that's b, divided by 2 times the negative 16. And that will be something you get to use a calculator on. So these worst problems, these are calculator based, so we would use calculators for this. And then you figure out that that is, what does that represent? So usually the vertex is the x-coordinate of your function, right? So when we did this with normal parabolas, the vertex would, this would give us the x-coordinate of the vertex with the x being in these two spots. So in these two spots, that's t. So the 6.25 is the time it takes to get to the maximum height. Okay, so that is the time needed to reach the maximum height. Well, that's not what I wanted. I want the actual maximum height. How high is that? So then you have to plug that in. So what we're actually after is the y-coordinate. Again, this would be a calculator part. You get a calculator, you plug in 6.25, you square it on the first, not on the second. You add all this mess together, and if you do this, I think you should get 627 feet. So this is the maximum height. So that answers question 1 there. Then it says, when is the rocket above 300 feet? Okay, so let me give you a quick little sketch of this parabola. That's a negative leading coefficient. So overall, the parabola that models this function looks like this. We just found the maximum height. Okay, and actually we do know that it starts at 0 and then it ends at 0. So let me actually erase some of this stuff. We know that because, you know, it's a real life problem, at 0, t is 0, the rocket hasn't gone up yet, then it goes up as time goes by, and it comes back down as time goes by. We just found that this point occurs at t is 6.25, and at a height, this would be the distance at that time of 627 feet. So now they're asking me, what t do I get? Do I need to be above and then back to the maximum and back down? So the t that I want is the t that is from here to there. Well, that's a quadratic that you can solve. You can say, well, 300 is equal to a negative 16t squared plus 200t plus 2. That should give me the 2 times that this rocket is exactly at 300 feet. In this case, I'm going to actually move the 16t to the left, move the negative, move the 200t over here, and you get 300 minus 2 will be plus 298 equals 0. Solve this with the quadratic formula. So usually we would write x here, but in this case we're solving for t. So t is a negative b plus or minus the square root of b squared minus 4ac divided by 2a. So it's a negative 200. So that actually becomes a positive 200. And then we square the negative 200. And then minus 4, and a is 16, and c is 298. And all this is divided by 2 times 16. Okay, so that means t is, and I would do it this way. I would now get a calculator and figure out what I get underneath. So in the calculator, I would just type in this part, the negative 200 squared minus 4 times 16 times 298. And that gives me 20,928 divided by 32. Sorry. The reason I would do that first is because I said a while back we actually should get 2 t's, so now you can split it. So now the first t would be 200 minus the square root of 20,928 divided by 32. Okay, so you figure out what that would be, and that would be 1.73 seconds. So after 1.73 seconds, the rocket is at 300 feet. And then the second t that we want would be the 200 plus the square root of 20,928. Divide that by 32, and that gives you 10.77 seconds. So the rocket is above 300 feet when the time is between 1.73 and 10.7 seconds. Now the round brackets here means, again, that the 1.73 is not included, right? Okay, so it's the first time after 1.73. So if you graph this as an inequality, which it is actually, you would say 1.73 open circle to 10.77 with an open circle, and you could connect it this way. So you could answer it this way as well, but that looks sort of funny. Or you could literally write it as a sentence. The time that the rocket will be above 300 feet is between 1.73 and 10.77 seconds. Okay, there's actually a third question. The third question says, when does the rocket hit the ground? So there's question number 3. The rocket hits the ground after a certain amount of time. It starts at 0 and then it comes back. So the formula, or sorry, the model here is the distance above the ground. Well, when the rocket is on the ground, the distance above the ground is 0. So we're actually being asked to solve this. Well, that's very similar to what we just did. We used the quadratic formula. In this case, it's a negative 200 plus or minus 200 squared minus 4. That's ugly. I can do that better. Sorry. Minus 4 times a negative 16 times 2 divided by 2 times a negative 16. Again, I would figure out what I get underneath the square root with a calculator, which in this case is 40,128. And then I'm dividing by a negative 32 in this case. And then I would split it, and again I would get 2 answers. I would get a t that's equal to a negative 200 minus the square root of 40,128 divided by a negative 32. So that's a negative minus another negative. So you get a negative here. 2 negatives, this is actually a positive answer. This would give you 12.51 seconds. If you did the other one first, and you did a negative 200 plus the square root of 40,128, and then divided that by negative 32. By the way, on your calculator, you should have brackets there. If you do this in one step, these are in brackets, and then divide. Or you enter this on your calculator first. Then you hit enter, and it gives you an answer, and then you say divide that by negative 32. So you get an answer here, and then divide it. When you do this, you get a negative 0.01 seconds. Well, that doesn't make any sense. There's only one answer here. Okay, it hits the ground after basically 12.5 seconds, a little more than 12.5. Okay, that's it. Thank you.